Welcome back to Advent of Code 2023, day 2. I started a bit late today again. So yeah, yesterday didn't go great. It's supposed to be an easy problem. Well, it was tricky, but it wasn't just me. A lot of people fell into the same pitfalls that I did. Trying to replace things in a string. In the end, an iterative... I mean, to be honest, someone who's just started programming probably wouldn't really know about string replacing and stuff. They would go for the most naive brute force method, which is to just go character by character. And they would probably get it right, so... This was an example of a problem where I definitely overcomplicated things. But that's not to say you should always be... I mean, sometimes you do need to overcomplicate things, so it's... Okay. But sometimes you do need to always consider whether the brute force method would really just suffice and be codable in a reasonable amount of time. Well, day 2 then. Cube Conundrum. You're launched high into the atmosphere. The apex of your trajectory just barely reaches the surface of a large island floating in the sky. You gently land in a fluffy pile of leaves. It's quite cold, but you don't see much snow. An elf runs over to greet you. The elf explains that you've arrived at Snow Island and apologizes for the lack of snow. Well, I mean, we're in the sky. There wouldn't be snow in the sky, would there? Snow forms a bit lower down. Otherwise, when you're in a plane, you'd be crashing through snow. He'll be happy to explain the situation. Oh, no, it's just a very high island, like in Minecraft, okay. It's a bit of a walk, so you'll have some time. They don't get many visitors up here. Would you like to play a game in the meantime? Oh, it's a bag of marbles game. We had one like this in 2018, or last year actually. As you walk, the elf shows you a small bag and some cubes, which are either red, green, or blue. Each time you play this game, he will hide a secret number of cubes of each color in the bag, and your goal is to figure out information about the number of cubes. To get information, once a bag has been loaded with cubes, the elf will reach into the bag, grab a handful of random cubes, show them to you, and then put them back in the bag. He'll do this a few times per game. You play several games and record the information from each game. Each game is listed with its ID number, followed by a semicolon separated list of subsets of cubes that were revealed from the bag. Uh-huh. So this is with replacement, okay? So you get 3 blue, 4 red, 1 red, 2 green. Oh, so it's a different size handful each time as well. It's just an arbitrary handful. Okay, fine. Okay. The elf would like to know which games would have been possible if the bag contained only 12 red cubes, 13 green cubes, and 14 blue cubes. So game 3 would have been impossible because at one point it showed you 20 red cubes. Oh. Okay. Fine. Okay. We're not gonna overcomplicate it this time. I think I know what to do. So Create a new file. Alright, so we've... Where's our input? Okay. We've got 100 games here. No, not... Yeah. There we go. So I suppose... we want to... It's not even in order, so the first one could be green, it could be... Okay, I get it. Alright, so the first thing we want to do is parse the input. Well, okay, so... We might as well do this while we're processing the input. So we say... we want the number of games that are... possible. Okay. Okay, so for each line. So the limit they've proposed is 12 red, 13 green, 14 blue. So it's limit equals 12 red 12 green 13 blue 14. Okay, so for each problem, we're gonna have to do this parsing. So we're gonna say, let's say pix equals, so it's gonna be line dot strip. Let's take position 8 onwards. And then split it by semicolon. So each pick will be something like this. Ends at the semicolon space. It's gonna be like green, red, okay. Also, we don't need this dictionary. Let's just say G limit R limit equals 12, G limit equals 13, B limit equals 14. Okay, so we've got our picks for P in picks. So for each of these, we want to check if it's impossible. If it's impossible, we move to the next game. If it's possible, we just move to the next pick. All right, so we switch blue through. So for part in P dot split. So we look at a specific part, and then it's going to be num color equals part dot got picks and parts. Not grid variable names. All right. Dot split. What is it? Just a space. Okay. All right. Num equals int num. All right. So. Oh, no. The dictionary is what I wanted. Whoops. Let me go do that again. This is the reason I made the dictionary. Because then I can do this. Why did I delete it? Could have Control Z, but then I have to. Alright, whatever. Now, if num is strictly greater than the limit for that color, impossible equals true. Now we have to say alright, for P and picks break. Oh, whoops, sorry, I didn't change the... Huh? Why is the screen on the website? What happened there? How long has that been there? Have I just been showing the website all this time? Oh no. Alright, well... Something malfunctioned in OBS there. Okay, anyway. Alright, so what I've done so far, if you haven't really been following, I've made a limit. And then we parse each line one by one. Create an impossible. So the moment this goes true, we move on to the next line. Okay, so impossible is false. So if we see that num is greater than what our limit allows, we set this to true, break out. If possible, break out of this loop. Alright, so if not impossible, we'll just say num possible plus equal int. We'll just say it will automatically cast, so not impossible. So if it's possible, we add 1. Is that it? Num color equals part dot split. Also, we need the int. Also, we're not supposed to print the count. Supposed to some possible. If not impossible, some possible plus equal, it's going to be I plus 1. Okay, so, but still something's gone wrong. Why is this not unpacking? Num color equals part split. Alright, print. Gotta print some stuff. Didn't happen that time. No, it did. There's an extra space here? Oh, because of the... Stupid. So... let's just say... line dot find colon +2. So just go 2 after the colon. Will that work? Okay, 2528. Right, remember to switch back from the website. Okay. The elf says they've stopped producing snow because they aren't getting any water. He isn't sure why the water stopped. However, he can show you how to get to the water source to check it out for yourself. We're going by Trebuchet again? As you continue your walk, the elf poses a second question. In each game you played, what is the fewest number of cubes of each color that could have been in the bag to make the game possible? For each game, what is the fewest number of cubes of each color? So we're basically just taking the max of each color we've seen, right? The power of a set of cubes is equal to the numbers of red, green, and blue cubes multiplied together. Okay. Fine. I know what to do. So, okay, so that's... So... Okay, so we no longer break. Right. We just set that to true. Alright, so that's part 1 logic. Part 2. Okay, so we've got what we need for part 1. For part 2, we don't care about that. We want to, so we want to compute the fewest possible. Okay, so min possible equals, so it's going to be, to begin with, the minimum is 0, 0, 0, 0, right? And every time we see a higher number, we just increase it. So we say, once we've got this, we say min possible color equals max of whatever it was, and the new number we've seen, right? And then, so once we've done all of that for this game, the power equals how do we do this? Power equals 1 for b in min possible dot values power multiplied by v, so that's just the multiplication of all of them together. Product. Is that what how they compute it? Multiplied together, yeah. So sum of the power of these sets. So we just want to sum powers. Hello, Irving TX. Let's see. This could be all there is to it. So is my logic right? So the minimum, every time we see a higher number of marbles, cubes, whatever, that pushes the minimum up. What's the final number? 67. Sounds plausible, I guess. Correct. Okay. This was a better day than yesterday. Or our performance was better than yesterday. What a mess yesterday was. Also took me half the time. Are you doing Advent of Code as well, Irving? So, let's check out the stats. Wow, look at this. So far, it's only been 24 hours and 108,000 people have completed part 1. Day 1. Hello, Noir Pie. And yesterday easier than today. I mean, you're right, it is at the very base of it. It is in principle an easier problem than today's problem, yeah. It is just look from the left to find a certain string, look from the right to find a certain string. It's just a huge trap that a lot of people fell into. But yeah, you're right, it is at the very core of the algorithm a more easy thing to do. Out of interest, Irving, how did you find my day 1 video? Did you find it on YouTube? Getting my head around today's problem is very annoying. Yeah, I can see that. Like, if I didn't use a dictionary, I guess I would use just individual variables for red, green, and blue. But yeah, the logic for the second part, not entirely trivial at first glance. YouTube, yes, nice. Oh, it's like, it looks like I got about 50 views for that, so people are finding it in YouTube. So this was very popular. 100. So let's look at the previous years. 2022. So, okay, this is year 2022, but this is accumulated over the entire year. So people have, you know, over the past year, people have been chipping in. So that's like almost 300,000. But this was day 1. That must have beaten day 1 from last year. That's quite a lot of people. All right, and part 2. So the fact that there's mostly gold stars and not many silver stars means a lot of people who completed part 1 were successful in also completing part 2. Makes sense. I guess once they had the framework for counting stuff per game, it wasn't too much work to then complete part 2. Part 1, see, that's a very high proportion of silver stars. That means a lot of people got stuck on part 2. Let's That's the funny thing. I had more struggle with part 1 than part 2. Yeah, so I guess these stars reflects that, because... Wait, are you talking about day 2, Pi, or day 1? Let me get the rest of my coffee. Day 2. Yeah, that seems to be in line with what we're seeing here, because if there's not many silver stars, that means once people completed part 1, it wasn't much work for them to go on to part 2, yeah. If you see it, for day 1 here, you see a lot of silvers, so lots of people just didn't do part 2. Part 2 of day 2 is easier than part 1. Yeah, I can see that, because I didn't have to... In part 2, it's literally just accumulating a max value, whereas in part 1, there's just like a conditional logic here with a break condition. Actually, I didn't need the break condition in the end, but yeah. Alright, so what was the... Also, everyone at home is also welcome to join my leaderboard if you want to. Oh, looks like we got some new joinees. Kenneth McDaniel, Aaron, is that Darichi? I'll post the link here. The code, I mean. So, I mean, I don't treat it as a leaderboard. It's just it's just based on how many stars you get. I don't care about who completes it first, because clearly I didn't start myself at the time that the problem opened. But yeah, it's just a fun thing to compare. Umaro is a long-term viewer of mine. I guess they haven't... oh! Wait. What is it? Yeah, no, they haven't tackled problem 2 yet. And what else did I want to look at? The day stats. How do we get that? It's always confusing because I don't expect the day 2 stats to be in... Oh no, you would expect it. Yeah, okay. 1 minute 34 to complete both stars. Yeah, sure, I can believe that. It's actually shorter than yesterday's because you don't have to parse all those words 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the bit which would take the longest for the pros. For this one, you just go line by line. You can do all the logic per line of input, so you don't have to accumulate all the input and then do some extra logic. Not that you had to do that yesterday either, but yeah. 37 seconds for the first part. Sure. Trying to see if I recognize any of these people. Not really. Okay, well then that's a fairly short stream then. Half an hour. Nothing more to do. We'll just wait until tomorrow then. And next year, let me just grab the rest of my coffee. Next year, I'll try to also catch up on 2019 and 2021, so I'll be a 450 star holder. I'll be finally caught up, I hope. I know what people are dreading though. They're dreading the assembly code problems. Assembly code is the one that Eric loves to throw in. These types of problems where you got assembly code, but with these custom instructions, and you gotta You gotta kind of semantically interpret the program that he's given you, or find some condition to make it stop, to not get stuck in an infinite loop, stuff like that. It's quite tricky, but quite cleverly written, I've got to admit. What do we think this is drawing here? It's like a cloud because we're in the sky. All right. All right then. Maybe I'll see you guys tomorrow. And thanks for the follow as well, Irving. I now have to process the video, upload to YouTube, do all that stuff. And I've got to get lunch because it's like 3:30 p.m. and I haven't eaten yet. All right. Thanks everyone. See you tomorrow. Where's the end stream button? There it is.